I will talk about why we need calibration, why we need wavelength calibration in spectral domain OCT setup. So in OCT, actually we measure the interference of reference and sample arm. So this is the interference of the reference and the sample arm. Then if we subtract the DC part from this data, we will find the pure interference here. And if we do the FFT of this data, the interference data, then we will find the depth profile. Now this FFT relates the physical distance G with wavelength number K. So there is a relation between G and K. By using the FFT, actually we convert the G with K, and K equal to twice pi by lambda, while lambda is the wavelength of the laser source. Now one problem is that the spectra that we get in K space is not evenly spaced. It's not evenly distributed. So what will happen if the spectra is not evenly distributed? For the incorrect wavelength assignment, the depth dependent broadening will happen. That means the coherence peak that we will get, that will be broadened. So that's one of the problems. So that's why we need proper wavelength assignment. Say here there is a two image, one with no calibration and one with calibration. So if you look at the image, top image, or there is no calibration, we can see that image is kind of broadening here. And when there was a calibration, when we do the calibration, that means properly we assign each wavelength as it plays, we see that image becomes sharp and image becomes clear. So in order to avoid this kind of effect, we have to do the wavelength assignment. We can see from the code too. Say if I run this code, so firstly I am just detecting the interference pattern. Then if I go forward and if I subtract the DC part from the image, we can only capture the interference part of the image. This is the useful part. From there we can, if we do the Fourier transform here, we can see this is before calibration. So this is the full image of all the line. Here we have 1024 lines, so we see the spectrum, and this is not looking sharp because we have only done just FFT of the data. Then if we do, and also if we do the other part, so this is for second camera. If you look at the depth profile before wavelength calibration, it's not sharp, and after wavelength calibration we can see that image looks sharp. If we compare this image, figure number 3, this image is this image is without calibration and this image is with calibration. We can clearly see that if wavelength is not assigned properly, then we will not be able to get the sharp image. That's mentioned here, that we will not be able to get the sharp image. There will be broadening of the peak. Peak will be broad. So that's why we need the calibration. Next I will talk about what are the techniques to find the calibration file. How can we get the calibration file.